Let's suppose that we're asked to solve for x. So we have 6 different problems here. And we're going to use our properties of logarithms in order to solve these equations. The first thing that we have to remember is that the relationship log base a of x equals y is exactly the same as a to the y equals x, as long as a is positive, a is not 1, and x is positive. We can't do much with logs if we don't remember that relationship. So this first one, in order to solve for x, all we're really going to need to do is just convert it to its exponent form. The corresponding exponent relationship would be 2 to the 5 equals x, which means then that x is just 32. Again, we can convert this to its exponent form. 2 to the 5 equals 5x plus 2. And now we just have to do a little bit more solving. 2 to the 5 is 32 equals 5x plus 2. We'll subtract 2 from both sides, and we'll have 30 equals 5x. Divide both sides by 5, and we have x is equal to 6. Here, we'll do the same thing. We'll convert it to its exponent form. X squared is equal to 100. Then if we square root both sides, we're going to have to think about something here. Always before, when we use the square root property, by taking the square root of both sides, we'd have to do a plus or minus on the right. But that would give us plus or minus 10. And one thing that we remember is that this base has to be positive. So we would disregard the negative solution that we got here, and we would say, okay, well then x can only be 10. That brings up another point. In order to check these things, all we would do then is just plug them in for x and then make sure that they work just like normal. So this would say that the log base 2 of 32 is 5. Does that make sense? Well, yes, it does, because if we convert it to its exponent form, it would be 2 to the 5 is 32. This problem here is a little bit different, because if we convert it to its exponent form, our variable is going to wind up in the exponent. Not an easy place to solve. But what we might do is look at this log base 4 of 16 thing here and realize that we could write 16 as 4 squared. And we recall our property that says log base a of a to the x is x. So this side here is just 2. So we have 2 is equal to 4x plus 2. If we were to subtract 2 from both sides, we'd have 4x is 0, which just tells us then that x is 0. In this case, when we solve for x, we may not get a nice number like we did in all of these other problems. We may actually wind up with a log in our answer. But we have to keep in mind that if we are trying to find an exact value, then we will not be using a calculator to approximate a value. We may need to express our value in terms of logs if we're only going to express it as an exact value. So let's see what happens here. One thing that we could do is convert this to its log form. Its log form would be the natural log of 7 is equal to 3x plus 4. And that's just using this log relationship again. If we write that relationship with e as the base, so in other words, the natural log, all it says is e to the y is x. Again, we have to remember this and be able to use it. So that's all we've done here. We've taken and written its equivalent log form. And then we can solve for x by subtracting 4 from both sides. So we'd have 3x is equal to the natural log of 7 minus 4. And then just divide both sides by 3. So we wind up with x is equal to the natural log of 7 minus 4 over 3. We have another one here that we're going to solve. It says 5 times e raised to the point 2x is 6. Now this is similar to the previous problem, except that rather than having e by itself raised to some power, it's being multiplied over here by something. Well, that's easy to deal with. All we would do is just divide both sides by 5, and we would have e by itself again. So we have e raised to the 0.2x is equal to 6/5. And again, converting it to its natural log form, we'd have the natural log of 6/5 is equal to 0.2x. We'll divide both sides by 0.2. And we have x is equal to the natural log of 6/5 divided by 0.2. Now this might not be considered a simple form because of the decimal in the bottom. We could multiply the top and bottom by 10 in order to move that decimal place. And we would wind up with 10 natural log of 6/5 over 2. But then the 10 and the 2 would cancel and make a 5. So we would wind up with just 5 natural log of 6/5 as our answer.